Hello students, welcome to the DC Machines and Transformers Lab videos. Uh, Today in this video we are going to demonstrate first experiment in the first cycle, which is open circuit and load characteristics of separately excited DC generator. So for that we have to first complete the connection diagram as per the circuit diagram given. We have connections made by seeing the cycle diagram available in the record notebook. We have to connect all the cycle. I just explained the cycle. The plus minus is the input. The DC input is to be connected with the DC motor through a rheostat. This rheostat is required to control the speed of this DC motor. This DC motor will act as a prime mover for this generator. And then external DC supply is to be given to the field winding of generator, that is called separately excitation, that can be controlled through this switch, SPST switch. And the output of generator is connected with the resistive load, and for controlling that output we have DPST switch. And for controlling the field current of generator we have the rheostat, another rheostat which is connected in series with the field winding of generator. So that is about the connection of this circuit diagram. You know, any generator will have some prime mover. This is the prime mover. Prime mover is DC shunt motor, and this is to be started with a 3-point starter. And the speed of this prime mover can be controlled using this field control method, field rheostat, right? So if you switch on this motor, this prime mover, your generator will get the mechanical input, and you require field current for this field winding of generator. It is taken from separate DC source so that it is separately excited DC generator. So once it gets the excitation and mechanical input, it generates the DC voltage, which can be taken from A1, A2, that is armature terminals. That A1, A2 output DC voltage is connected with the rheostatic load, resistive load, right? So now I'm going to demonstrate the thing. First, after making connections, ensure that all the connections are tightened, all the connections are correct, and the switches must be in open condition. And field rheostat of motor should be in a minimum position initially, and field rheostat of generator should be in maximum position initially. All the loads should be in off position, right? So after ensuring all these things, we can switch on the uh, machine, and we can take the readings, right? First switch on the MCCB. Sorry, this is RCCB. Switch on the DC supply so that you will get the DC supply, and switch on the prime mover, that is DC shunt motor, by using 3-point starter. Gently press inside and gradually move from this side to that side. So finally it gets hold on automatically. So your prime mover is running. First thing you have to check the speed of prime mover using the tachometer. This is non-contact type tachometer. So which is 1020 225 RPM. So but actually we have the rated RPM of 1500 is for this generator and the prime mover, right? So you have to set the 1500 RPM. That is by means of adjusting this rheostat, adjusting this rheostat, you can vary the speed and set that whether it is 1500, yes, it is 1463. Slightly it is to be increased. Yeah, we are increasing, and you are getting some 1500 RPM, 1530. So 1500 RPM is set. So after setting the rated speed with the prime mover, the field excitation is to be given, so that you have to switch on this SPST. So external DC supply is now connected with the field winding. So that can be seen from the field ammeter. There is some field current is flowing through the field winding, and so it produces some voltage. It generates some DC voltage that is available in this voltmeter. At present it is 57 into 2. So 110, around 110 volt is generated. And now we can start the open circuit characteristic. For open circuit characteristic, note down the readings of field current versus voltage. Now you can note down field current value and generated voltage value. And by increasing the field current, see that by increasing the field current using this rheostat, you can take down the reading. So I am increasing the field current. While increasing the field current, the voltage is increasing. Voltage is increasing, right? So I have to note down the readings of field current versus voltage. Field current versus voltage. This excitation is to be given up to the rated voltage. Here the rated voltage is 220. So I am getting 220 volt rated voltage is generated now. So from the initial voltage to rated voltage, you have to note down the field current versus generated voltage values, which is to be used for plotting the open circuit characteristic. So after reaching the rated voltage, you can switch on the load. This is a DPSC used to connect the load, resistive load. So after connecting the load, you can switch on one by one. This is 2 amps load is added so that 2 amps current is flowing. So for that, the voltage is varying. There may be voltage drop happening. So that can be seen. This is load characteristic readings. You have to take reading of voltage and load current. Terminal voltage and load current for load characteristics. So I'm adding another load, that is another 2 amps I'm adding, so that change in current, change in voltage. I'm adding another 2 amps, one more. So like that I can add the load, and for each load condition, different current and different terminal voltage values are taken as reading. And this loading can be up to the rated current. The rated current for this generator is about it is about 10 ampere. So you can load up to 10 amperes. So that's full load condition. At different load condition, what will be the voltage? That thing we can make as a reading for this experiment. Yes. After completing all the readings, you have to switch off the loads first, and then make the field rheostat of generator to initial position, and switch off the DPST connected with the load, and then switch off the field current, and make the field rheostat of motor to initial position, and then simply switch off the LCD. So with this, we complete the separately excited DC generator, open circuit and load characteristics of separately excited DC generator experiment. And with these readings, you can make calculations, and based on the calculations, we can draw the graph, and we can write the result and inference for this experiment. Thank you.